Hi. So, as we know, everyday companies are rushing to integrate LLMs into their products. So, for automated recruiting, risk assessment, and customer service, but there is a massive hidden risk. These models are trained on the internet, which means they inherit the historical human biases. Whenever it's gender stereotypes and in job descriptions or geographic discrimination in the safety scores, and deploying raw LLMs exposes companies to massive reputational and ethical and compliance risk. So we came up with the LMSense, the solution. So the philosophy is simple: bias mitigation should be layer, not a replacement. So instead of spending millions of dollars to build and retrain custom-safe models from scratch, LMSense lets you keep using state-of-art models like GPT-4, Claude, and Gemini 2.5, 3, 3.1, and so on. You simply drop LMSense in between your application and LLM. It acts as an intelligent firewall that detects debiases and audits output in real time. So how it works? So basically, let me give you one demo. Suppose here I'm writing one prompt, write a job description for a software engineer. I'm using a model like Nemotron 3. I could have used Gemini's 1.5 Flash, and here the raw response that we get is like this. But let's see what our LMSense layer is doing to this response. So I have run this. So see, there are three layers. One is QLoRA CDA, second is RLDF, and third is post-processing. So while comparing the differences between the raw output and the debiased output, we can see that here is one gender bias that our layer has detected and debiased it. Currently, since in my PC that QLoRA is not detected due to the NVIDIA's wheels are not supported. I don't know what the problem is, but yeah, I will explain the logic behind this QLoRA CDA fine tuning. Rest two layers, RLDF and post-process, are working fine. So yeah, so in layer 1 we use a lightweight QLoRA adapter trained on the counterfactual data to naturally tease the model neutrality. So basically we have fine-tuned on the final layer of any LLM and finding the biases and adding the weights. Basically we have used QLoRA there. This is our whole ML pipeline, and here there is an augmented.py, and here this is a pipeline.py. Here we have defined how our QLoRA fine-tuning will be working. So yeah, we have trained here using a train.py. Since in my PC currently QLoRA is not supported and it's not working, it is supported, but yeah, let's move on to the layer 2, which is RLDF. In this RLDF layer, basically we have implemented RLDF, as you know, reinforcement learning from multi-role debiases, and AI judge evaluates the text on the fly. If it detects bias, it dynamically forces off fairer rewrites. So here is the debiased loop. Here is the debate generation. So like debate prompts are write a job description for a software engineer, and these are some of the debates, and then there are multiple instances to do debate on as the particular RLDF framework we use it. And yeah, apart from that, there is layer 3, which is post-processing. Finally, an inference time guard uses projection-based embedding corrections to rewrite, flag, and completely block anything the first two layers miss. So yeah, this is our whole backend frameworks and these three layers. Apart from that, and here we can see currently there are no audits, but we can filter it whenever we want. And here we have the advanced options to configure our three layers. For QLoRA and CDA, we can just enable or not enable them, and then we have the layer 2. We can set the reward model, the judge. Here we have set the judge as GPT-4o. We can change the model. PPO epochs we can set by ourselves. Currently the epochs are 3, and the fairness is lambda is equal to 0.7 for the stricter judging. And for RL post-processing, enable layer 3. These are the thresholds and actions on bias. Currently these three models are integrated to a model, and yeah, this is the dashboard. Yeah, that's all for today. Thank you.